So part 2 of the video, we're going to go through the annotation of the margins, and this is going to help us determine what some of the important vocab are. So here I have the lesson completely filled out, and if I go to each bullet point, most of them have a vocabulary word. So on number 1, we kind of already talked about the fact that an observational study does not impose any treatments. So that would be something to highlight in the margin, is that no treatment was imposed. On number 2, we're looking at the explanatory variable, and that's actually what we're using to predict the response. So this first variable was like our independent variable. So we're using that to predict responses. And then the response variable was like the dependent. So this is actually the outcome, what was measured and what we're studying. For number 3, it's looking at whether or not we can conclude that the prep course caused an increase. And the reply would be no. We can only show cause and effect with an experiment. So if we wanted to show that, we would need an experiment to do that. On number 4, we're looking at some other variables that may explain the scores. And so this would be considered confounding or extraneous variables. And we need to make sure that we would control for those if possible, if we were doing an experiment, because these can actually affect the response. So we may need to look at the data in a different way if it's an observational study. Number 5 is actually asking students to design an experiment. So most students are probably going to just write a paragraph, but you can also show them a diagram that can be used to illustrate. So what I did was I looked at the sample diagram, and we took the 44 people that were listed as the volunteers. So we start with 44 students. We randomly assign them. There's different methods for random assignment. And we want to try to split them up into equal groups if possible. So we have 22 students in group 1 and 22 students in group 2. From there, group 1 would get treatment 1, and we could just call that the SAT prep class. And then group 2 would not receive the prep class. So after the class and after they took the SAT, we would compare the response, which would be the SAT scores. So notice that the random assignment comes first. So it's not like we let them choose who is going to the class and who's not. We're randomly assigning those. And the purpose of the random assignment is hopefully that it will equally distribute any of those confounding variables into the 2 groups, which means that some hardworking students will go in group 1 and also some will go into group 2. So they're mixed up with different kids. And so this would apply to any other confounding variables that could also affect the results. So when the treatment's applied here, after the random assignment, when the treatment is applied to each group, the only difference between the groups really should be the treatment. So if there is a significant difference in the SAT scores after we measure the response, then we can say that the SAT prep class caused the higher scores. So only in an experiment can you establish the cause and effect. So you may give students a chance to write down that diagram, but have them keep the paragraph that they might have already written for number 5. Now, if we move to page 2, this is where you're going to formalize the definitions. So for the big ideas, we mostly are going to have vocabulary. So I have the vocabulary listed over here. So the first big idea was, what's an observational study? And we've talked about that no treatment is imposed. And this is where we only observe. So we take all of the records of SAT scores and we make observations about them. In an experiment, however, a treatment is imposed. So in the diagram that I showed you, we had 22 of those students who were taking the class, and then the other 22 did not. It allows us to show cause and effect, so allows for causation. The explanatory variable is what we use to predict, and it is like an independent variable. We can have more than one. In this case, we did only have one. And they're actually called factors. And if you have more than one, You can have multiple factors, and each of those factors can even have different levels. The response variable is what we described as our dependent variable, and this is actually the outcome that is measured. These are the results that we're looking for. The treatment is actually what is done to the participants. So in a case like this, some took the class, some did not. So we would say that would be maybe a dummy treatment. If you had a clinical trial and you were testing medications, some people might get the new medication and some people might get the old medication. But of course, we don't want them to know which treatment they're getting. Experimental units would be who or what gets the treatment. In this case, we would call them subjects because they're people. But you could test different foods for dogs. And so those would be the experimental units of who is actually getting the treatment and who is getting randomly assigned to the treatments. And then finally, the confounding variables are any extraneous variables that are not controlled for that affect the response. So it's very important to have controls set throughout the experiment so we're able to determine whether or not the treatment was what actually caused the response. This also makes us unable to determine if the response was due to something else. So now that we've completed the annotated notes in the margins and also the big ideas, please complete the Check Your Understanding. There's just a couple of questions that will apply what was learned in this lesson.